another example which relies on three kind of models. The purpose of this application is to reimagine an image. Building blocks of this application is it accepts an existing image from your system and it describes the image using image to text model, which is llava 7 billion parameter model. So once the description of the image is ready, the description is given as a prompt to the language model to refine it, to reduce it, optimize it within 77 token. It is given as an input to the text to image generation model. Further, the model will generate a new image from an existing concept. So let me show you how this application works and how the results are. Again, I have taken the leverage of LLM util, which I have shown earlier. From the argument parameters, I have taken input image path and output image path. And once after having this, the reimagine process starts. As I said, first it generates the description for the input image. Once the description is available, we refine the description using the text model. Once the text model does the job, we get the image prompt and we further customize it and give it to prepare a new prompt to generate the image from this reimagined prompt. Let's also see what kind of models I am using. So far I haven't worked with the image models. This is the first time I'm working. Here we have a model which is from the runway and stable diffusion v15 with the CPU support and torch type. Float 32 is actually suitable to my laptop's computational power. If I go with the float 16, my laptop is unable to execute this language model and it is crashing. My laptop doesn't have that much computational power to execute this image model. Well, I have taken two kind of imaging models for the experimentation purpose, just to compare the outcomes, how different image models would respond to the image and prompt. The SD Turbo supported by stabilityai and the input parameters are same. So all these were come from diffusers package. So first we need to install the diffusers package, then we can start using them. So let me run this now. So let me show you the input as well. So I'm giving my own image as an input. I'm using as a cover page for my portfolio as an input, and I want to see how these models will recreate by understanding imaging features from the given input. Let me give input.jpg as my first image. The text to image models requires lot of computational power and it will take nearly 3 to 4 minutes execution time to generate the images. So I'll be forwarding the video a little bit to see the final outcome. So this is the generated description. So let's come back here. So the llava 7b has generated the description out of the image. So here you can clearly see the image depicts a person sitting at the gaming setup, recording a video or streaming on a platform like YouTube or Twitch. Correct? Exactly. The individual has a dark hair and is wearing a t-shirt, etc, etc. So it is literally put all the information in detail, whatever it understood from the image. So if we compare the image with this description, it actually matches almost. You can see the image prompt, the refined version of the same description, whatever text we got from the image. Llama 3.2 has optimized all these 4 paragraphs into a single paragraphs with a less description under 70 tokens. There is no visibility of any headphones. So all it sees is back 3 lights sitting for a podcast episode. So most of the information is correct. So let's see the output generated by these two image models. There is a limitation to this runwayml stable diffusion v15 because it accepts only 77 tokens in the prompt to generate an image. I have taken the help of llama 3.2 to refine the image description and limit it to 70 tokens. So here I have given a prompt saying that limit the description below 70 tokens and don't add your any personal thoughts, hallucinate anything. Seems like it is 8 minutes already. The first image from stable diffusion is already out. The second one is SD Turbo is generating the image now. So both the images are done. Let's wait and reveal what's the output of the reimagination. So I got both the images. Let me open side by side. This is the input and this is by stable diffusion. Okay, and this is by Turbo. I'm not expecting they redraw my image, actual image exactly. I just want to experiment what kind of detailing they take in as an input and how they regenerate the image. Basically, they got covered most of the attribute, but I feel SD Turbo is more relevant than the stable diffusion output. You can see all the details here. The mic is in front, there is a light which looks like camera, and it's most like a studio room. But whereas the stable diffusion seems like a normal office chair, and it doesn't look like preparing for a broadcasting. So this is the surprise. I'm saying it first time and for you guys as well. So if you want to try based on these results, you can choose whichever model you want to try, or if you are already using a better one, please do comment under this video so that I'll be aware and others who are following this series will be also aware other popular imaging models.